Hi, here we'll try to solve a problem called coin change. So the input is coin denominations and the output is like minimum number of coins of those denominations required to make up this amount. There are two type of problems here. One is you have to make use of only finite number of coins and the other is infinite number of coins of these denominations. So in this video we'll try to solve the other problem like infinite number of coins. Here is the problem description. So you are given with some coin denominations like 1, 2, 5 and some amount like 11. So by using these coin denominations any number of times, return the minimum number of coins required to make up this amount. So here to make up this amount like 11, we can have these coins like these three coins 5, 5 and 1. There will be like 3 coins. So return 3. And there are other possible combinations like 2 5 times and 1 as ones, so that will be like 6 coins, but that will be larger than these 3, so we should not return that value. So the answer is 3 here. And if you take the other case wherein we have a denomination of only 2 and the required sum is 3, so by using just this coin any number of times you can't make up this amount, so in that case just return -1. Let us try to understand the problem statement by looking at an example. So if we take an example array of 1, 2, 3 coin denominations and amount as 4. So to make up amount 4, the possible combinations can be like 1 plus 1 plus 1 plus 1 and 1 plus 1 plus 2 or 2 plus 2 or just 1 plus 3. So these are all the possible combinations. So this requires 4 coins, this requires 3 coins, this requires 2 coins and this requires 2 coins. So the minimum is like any of these two, like either we can take 2 plus 2 or 1 plus 3. So the answer is 2. But this way of solving the problem is not possible because there is no systematic way to identify the possible combinations. So let us try to identify a way to generate all the possible combinations to make up this amount 4, and then we can choose the minimum coins answer out of all those things. So let's start with the amount, required amount as 4. To generate 4, so I can choose any of these coins first. Like I can start the solution with any of these coins. So I can choose 1, I can choose 2, I can choose 3. So 1, 2, 3. So if I chosen 1, that means to generate amount 4, I have already got a coin of denomination 1. Then I need to find remaining coins which will make up amount 3. Similarly, if I choose 2, then I need to find an answer for 2. If I choose 3, I need to find an answer for 1. Then for 3, the similar thing. Since we got infinite number of coins, we can again choose any of those 3. So to make 3, let's take any of these 3 choices. 1, 2, 3. So if I choose 1, then I'll be finding the answer for 2. Then if I choose 2, if I have to find the answer for 1. If I had chosen 3, then I got a result of 0. So 0 means, yeah, we arrived at some answer. That means, yeah, we got a valid combination. And to find the answer for 2, again we have three choices like 1, 2, 3. If I choose 1, I need to find the answer for 1. For 2, I need to find the answer for 0. And for 3, I need to find the answer for -1. So -1 means these are invalid combinations. So if you take a look at this, to make up amount 2, I have only choice like 3 here. So by using coin of denomination 3, there is no way for me to generate this amount. So this is an invalid combination. And we got 0 here, so this is a valid combination. We can stop here. And for 1, again we'll be having 3 choices. 1, 2, 3. So if I choose 1, I'll be getting 0. So this is a valid combination. If I choose 2, -1, invalid. If I choose 3, -2, invalid. Then for this one, again like 3 choices. 1, 2, 3. So if I choose 1, 0, valid combination. This is -1, this is -2, invalid, invalid. Then for 3, again we have 3 choices. 1, 2, 3. So if I choose 1, I need to find the answer for 1. Then 0, this is -1. So this is invalid combination, this is perfect. Now for 1, again we have 3 choices. 1, 2, 3. If I choose 1, 0, valid combination. This is -1, invalid. This is -2, invalid. Now we are left with this one. Again we'll be having 3 choices here. 1 2 3. So if I choose 1 0, valid combination. This is -1, invalid. This is -2, again invalid. Now if we take a look at all the valid combinations, so I got a result here. This is 1 plus 1 plus 1 plus 1, and I got another result here. This is 1 plus 1 plus 2. I got another result here, 1 plus 2 plus 1, and I got another result here. This is 1 plus 3, and this is 2 plus 1 plus 1, and this is 2 plus 2, and here I got 3 plus 1. So in total I got like 1 2 3 4 5 6 7 combinations, and out of all these 7 combinations there are some duplicates like 3 plus 1, 1 plus 3, or 2 plus 1 plus 1, or 1 plus 2 plus 1, 1 plus 1 plus 2. So if we avoid all those duplicates, so we have a valid answers like 1 plus 1 plus 1 plus 1, and 1 plus 1 plus 2, and 2 plus 2, 3 plus 1. So out of all these 4 combinations, the minimum coins required for is like these 2. So the answer is 2 here. But how to formulate that answer? By using this recursion tree. Now if we take a close look at this, like this each branch, let's say, so at this, when we are at this amount, so we haven't collected any coins till this, so that means yeah, we are having 0 coins with us. Now at this point, to reach this branch, we have to choose 1 coin and come this level. So that means we are left, we are having 1 coin here, so any of this level, like, and if you come 1 level down, so we'll be having 2 coins with us. If we further down, like 3 coins, it is 4 coins. Now if we take a look at this particular branch, so to get the answer for amount 4, so like answer of 4 is like, I have to go 1 level down. That means to go 1 level down, I have to spend a coin. It can be any coin, 1, plus I need to take like whichever gives me minimum value out of these things. It's like to make 3, if I get minimum value, then yeah, I have to choose 1, or like to make these amounts, if I get minimum value, then I have to choose one of these 3. So I have to take minimum, so I have to take minimum of like answer of 3, this one, or answer of 2, or answer of 1. So this is kind of a formula for us. So if we take a look at this whole branch, so we have like 3 possible cases. So at one point we are getting amount as 0, that means yeah, we don't need to spend any coins, and at some point we are getting some negative value, that means it's invalid combinations, so we can just avoid that, we can just ignore that. And other cases like a valid case, by using this formula we can solve that. So let's try to formulate that particular thing. Like 3 cases are, first thing is my required amount is 0, and my required amount is less than 0, and other case is amount greater than 0. So if it is 0, that means just straight away return value 0, I don't need to spend any coin. If it is less than 0, then as stated in the problem statement, we have to return -1. If it is 0, that means we have to use this formula. So I'll make use of this formula, like 1 plus minimum. So I have to consider all the possible values inside my coins given array. So I equal to 0 to then -1, and I need to find the answers for answer of amount minus like coins of I. So these are the 3 cases which we need to consider. By using these things, we can write the program. But this is a recursion tree. That means yeah, if you take a look at the possible number of branches, so at each level the branches are getting increased by like the number of coins which are given. So at this level we have 3 branches. At this level we got like 3 power 2 branches at this level. So if at all these are some valid combinations, I'll be getting 3 power 3, and at this level 3 power 4. So I need to go like number of branches equal to the minimum coin whichever I have, like number of levels down, it's going to be like minimum. So that way it's going to be like my total time complexity is going to be the number of coins n and the total sum, it is s here. So n power s, so in this case it's going to be 3 power 4. But yeah, since there are some invalid combinations, because if I have to make up amount like 10 and I'm having only coin 1, so I can't go like more than 5 levels down. So that means, yeah, 10 by 2 it is 5 levels down. So it's going to be, instead of n power s, it's going to be mostly s power n, because s by c1 into s by c2 s by c3. So the time complexity is going to be something like this, which is nothing but s power n. So tc is s power n, and space complexity is like the depth of this recursion tree. So let's assume it as O of maybe s. So if we observe this recursion tree closely, we are finding the answer for 1 here, and again we are finding the answer for 1 here, and again here, and again here. Similarly for 2 also. So here and here. That means we have some repeated subproblems and we are trying to find the answers for all those things again and again. That'll definitely increase my time. So if you can avoid calculating the subproblems again and again, and if I store that results somewhere and then make use of them, that definitely decrease my time complexity. And other thing is that each of my recursion branch, like this branch or this branch, whatever it is, will definitely return me some value. Out of these 3, it will return me any of these values. So I have 2 properties, like my recursion tree will definitely return some value, and I have some repeated subproblems. So this will make me to think of dynamic programming usage here, which will reduce my time complexity. Let us explore dynamic programming here, which will make use of some memory to find the answers for repeated subproblems. Since I need the answer for 4, so let me take an array of size 5. So this is nothing but my amount. So amount 0, amount 1, amount 3, amount 4. So I need to return the value of 4 at the end. And the base case is like, if amount is 0, my answer is 0. I don't need to take any coins to form 0 amount. Now let's start with like amount 1. So to find the answer for amount 1, so as we see this one, since amount is not less than 0, it is greater than 0, so we need to make use of this formula. So it is 1 plus minimum of, so answer of like amount is 1 minus my coin, first coin, it is 1 minus 1, and the next is 1 minus 2, 1 minus 3. Since this is minus 1, this is minus 2, invalid, so we don't need to consider these things. So this is 0, so it is 1 plus minimum of just the answer of 0. So the answer of 0 is, we already know it is 0, so it is 1 plus 0, it is 1. Then we can move on. Answer of 2 is 1 plus, it is amount is 2, 2 minus 1, 2 minus 2, 2 minus 3. So this is invalid, this is 0, this is 1. So the answer of 1 is 1, the answer of 0 is 0. Minimum of these things is 0, so it is 1 plus 0, again 1. Now the answer of like 3 is 1 plus minimum of 3 minus 1, 3 minus 2, 3 minus 3. It is 2, it is 1, it is 0. And the minimum is like at 0, I have 0 value, and for these things it is 1, it is 1, it is 0. So minimum of these 3 things is 0, it is 1 plus 0, again 1. And the answer of 4 is 1 plus minimum of 4 minus 1, 4 minus 2, 4 minus 3. 4 minus 1, 3, this is 2, this is 1. So for 3, I have the answer as 1. For 2, I have the answer as 1. For 1 also, I have the answer as 1. So minimum of these 3 things is again 1. So 1 plus 1, it is 2. So my question asked me to find the answer for 4. So I need to return this value. Let us try to write the program for dynamic programming approach. And as we discussed, we need some memory to store the repeated subproblems answer. So let's keep an integer array for that. So memory equal to new int. So length of it is going to be amount plus 1. And we need to iterate over each and every possible sum, like sum equal to 1 till sum less than or equal to amount sum plus plus. So for each such subproblem, let's assume the initial answer is like integer max, since we need to find the min value. So let's take max value. So what are the value I found less than this? I need to consider that. I need to iterate over all the possible coins here in j equal 0, j less than coins dot length, j plus plus. So I have three possible cases, like my amount minus coins is equal to 0, greater than 0, or less than 0. So less than 0 is invalid case, so I don't need to consider that. Let's write the program for other two cases. So if my sum minus coins of j is equal to 0, my answer is going to be 0. Else if sum minus coins of j is greater than 0, then my min is going to be what are the min I found till now and the current value. Current value is going to be taken from mem of like sum minus coins of j. And since we calculated the answer for this particular sum, we need to store that in memory. So it's going to be, and there's a case that it can be max value only. So we need to check that. So if my min is equal to integer dot max value, then I need to store that as it is integer dot max value only. Else I just need to add 1 to my min. 1 to my min. Then at the end I need to read the answer which is available at mem of amount. But there is a case that it is still integer dot max value, so we need to consider that case. So if it is equal to integer dot max value, then as stated in the problem statement, just return -1, else just return mem of amount. Run code. It gives the answer. Thank you for watching this video. If this was helpful to you, please do like it. If you'd like to watch more such videos, subscribe to my channel Layman Coding. If you have any comments, please write them below. Thank you.